Morning students, I am C. Radhakrishnan, Assistant Professor, CS Department, Kumar College of Engineering and Technology. Today we will discuss about context-free grammar, Unit 3, Introduction, about Turing theory of computations. Now we will start with context-free grammar is our output. What is the outline of the session? So today we discuss about first 2 points: context-free grammar introduction, ambiguity in the grammar. These 2 points only we discuss today. Context-free grammar. The context-free grammar we define in terms of 4 tuples. Context-free grammar we define in terms of 4 tuples. First one is a grammar we defined as a finite set of grammar rules which is in quadruple form in terms of VTPS or V in terms of N. Whatever you have to define, VTPS or NTPS, there is no issue. So the context-free grammar CFG consists of a set of grammar rules in the quadruples NTPS, where N is a set of non-terminals in the symbol and T is a set of terminal characters in the grammar. P is a set of production rules in the given grammar, and S is the starting symbol of the given grammar. So the context-free grammar we define in terms of VTPS concept. So that is our applications of CFG. What are the applications of CFG means? Context-free languages have a great practical significance, which is mostly implemented in the high-level programming concept languages and also to verified with the syntax of the corresponding programming language. The compilation process will be carried out for each and every languages. The compilation process, the verification of the syntax will be implemented with the help of context-free grammars. Context-free languages also used by compiler in terms of parsing phase at the syntax of the define the syntax of the programming language and are used in many editors. So these are all some examples of CFG. Examples of CFG, a grammar we call as set of states, a set of non-terminals, set of terminals, set of production rules, comma starting symbol. Here, VTPS we define as first one capital A non-terminal expression, A, B, C, 3 terminal characters are present, production rule represented in terms of capital B, starting symbol represented as capital S. The production rules are A gives small a capital A, second rule A gives A, B, C. This is one example. Another one example, capital S is a set of non-terminal. Set of terminal will be A comma B. Production rules are capital B. Starting symbol will be S. The production set of rules are P. Production rules are S gives A, S A, S gives B, S B, S gives epsilon. The another example is third one. S comma F, 0 comma 1 is input, P is a production rule, S is starting symbol. S is a set of production rules, S gives 0 0 S or 1 1 F. Two alternatives of production rule non-terminal S. And similarly, F gives defined in terms of 0 0 F or epsilon are two alternatives. Generation of derivation tree. From the given rule, we can parse it by derivations. Derivations means some input characters are derived from the given grammar. That is called as derivation. The derivation tree or parse tree, both are all same. The parse tree is an ordered rooted tree that graphically represent the semantic information in a string derived from a context-free grammar. This is the derivation tree definition. The derivation tree is nothing but it is a pictorial representation of the given derivation. Pictorial representation is our concept. The representation techniques we called as mainly focusing on three values. Main root node that we call as root vertex. The vertex concept will be discussed in the data structure. Here we represent as main root node, and the vertex is non-terminal, that means root node. Leaf nodes. Root vertex means must be labeled by the start symbol. So what is the starting symbol of the given grammar? That should be represented as a very main root vertex or main root node of the tree structure. And vertex are represented in terms of non-terminal, and the third point, leaves are represented in terms of terminal characters or epsilon symbol. There are two approaches for the parsed tree or derivation tree constructions. There are two approaches. First one, top-down approach. Top-down approach means from the root node to leaf node to be derived. Start with the main starting symbol capital letter S. Goes down the tree leaves using the productions. And second approach is bottom-up approach. Start from the leaf nodes and proceeds upward direction to the root node, which is the starting symbol of S. So top-down approach means given capital S2, the corresponding input is derived. Bottom-up approach means from the input is possible to reach the main root node, that is the starting symbol of the given grammar. That is a bottom-up approach. Derivation tree or yield of a tree. The derivation or yield of the parsed tree is the final string obtained by concatenating the labels of the leaves of the tree from left to right manner and ignoring the epsilon symbols. However, if all the leaves are null, derivation is null. This is the derivation definition. So, for example, consider example. Let CFG is equal to NTPS. Here N is capital S, T equal to A comma B. Starting symbol is S. Production rule P equal to SS or ASB or epsilon. So we can derive the string is ABA, ABB from the given CFG. So we start with capital SS. S is replaced by two alternative SS. Next, first S will be replaced to ASB, remaining S. Again, the ASB is derived as ABS. S will be replaced by epsilon, so ABS is presented. Now capital letter S is again replaced by ASB and remaining input ABA available, keep as it is. Now S is again replaced by ASB, ABA, ASBB. Now S is substituted as a epsilon, so AB, WA, This derivation will be purely derived from the given grammar. It depends upon the given input string. So from this input string, we need to be matched with the corresponding production rule. You need to be derived. This is the representation of the graphical. First one, S, replaced by S. Next S will be replaced by A, S, B. Next, this corresponding S is replaced by epsilon. And next S will be replaced to A, S, B. Again, S is replaced to A, S, B. Now S will be epsilon. So now you can read the input from left to right manner. A, epsilon, B. A, epsilon, B. Ignoring the epsilon characters. Finally, we will get A, B, B. A, B. This is our final output. From the tree representation, having some properties are there. There are 4 properties of the tree representation of the parse tree of the given derivation. Nothing but parse tree, properties of parse tree. There are 4 properties. First one, main root node will be pointed by only the starting symbol of the given grammar. Second one, interior nodes are represented in terms of non-terminals. Third point, leaf nodes are represented in terms of terminal values. And last one, read the input characters from left to right manner and ignoring the null characters. This is the way we are represented the tree representations of property. Leftmost derivation and rightmost derivation of the string. Leftmost derivation means a leftmost derivation is obtained by applying the production to the left variable in each step. So applying the production to the left variable on each step. So whatever the input derivation will be carried out, replace the character by capital letter to small letter in terms of non-terminal to terminal. We can consider in the left hand side onwards. Similarly, the rightmost derivation means the rightmost derivation is obtained by applying the production to the rightmost variable to each step. So we can concentrate on from the right hand side to left hand side. Example, let us consider the example production rule. X gives x plus x or x into x, and third alternative will be x alone. Fourth alternative will be A. So now over the alphabet sigma A. So what is it? I need to derive the string A plus A star. A means first x is replaced to x plus x. Why I am choosing x plus x? Because the given input first operator will be plus, so that the corresponding alternative production rule plus will be available. The corresponding variable x will be taken. So x gives x plus x. Now I required A is the first input. So first x will be replaced by A plus x. Next myself to replace capital X. I required another operator star. So corresponding x having another alternative x into x. One minute. Now x gives x a plus x. Now x is replaced by a plus x into x. Now second one, first x will be replaced to small letter a plus x. Again left hand side to right hand side. First capital X is replaced by a plus a star. A is our leftmost derivation. Next I will consider the inputs dash step for in terms of diagrammatic representation. First x is replaced by x plus x. In second step, the x plus x is already available. Just replace the leftmost x into small letter e. Third step, we concentrate on second x is replaced to x into x. In fourth step, from the left hand side, first that particular x is replaced to small letter e and star, remaining star. At last step, the last x will be replaced to small letter a. Now read the input from left to right manner. A plus a into a is our output. Similarly, for rightmost derivation, first x from the right hand side, star is my first operator, so that I replace x gives x into x. Again, I replace first capital X by small a. So x into a is gives. Remaining from the right hand side, a star available. Next, I required plus operator. So first x will be replaced by x plus x and remaining star a. Now from the right hand side to left, first x will be replaced to small letter a, remaining plus x will be presented. So now in the expression, now the particular situation, x plus a into a. Now replace the right hand side to left hand side of the non-terminal, x is replaced to a plus a star a. That is our derivation steps. What is the pictorial representation of the parse tree? The same way, x is replaced to x into x. The rightmost x first replaced by x into x gives a, and remaining at next step, the left x will be replaced to x plus x, and from the right hand side, the first x will be now is replaced to a in the step number 4, and finally the last x will be replaced by small letter a. Now the derivation will be a plus a into a. Our derivation set will be obtained. Our derivation steps will be in terms of obtained for the a plus a into a output. Ambiguous grammar. Ambiguous grammar means, what is the meaning? If a context-free grammar G has more than one derivation tree for some input means, there is a possibility for derive the input in terms of more than one different format. That means the grammar is called as ambiguous grammar. So we consider the distinct W, which is present in the language L, is called as ambiguous grammar. There exists a multiple rightmost or multiple leftmost derivation for some string is generated from that grammar. In generally, there is a possibility for more than two different parse tree is presented. We called as the grammar is ambiguous grammar. Consider the same problem. X gives x plus x, x star x or x is having the ambiguous or not. So definitely there is a problem is nothing but is ambiguous grammar. So the same way we have to derive the string a plus a star a. Derivation 1 in terms of leftmost derivation, x gives x plus x, a plus x, again x is equal to x star x, nearby a plus a into x, a plus a into a. Similarly, for the corresponding tree will be x is replaced by x plus x, first x is replaced by a, second x will be replaced by x into x, again x is replaced to a, star key as it is, x is replaced by a. So now a plus a star a our output generated. Similarly, the derivation 2, x is equal to x into x, again x first x replaced by x plus x into x. Now first x is replaced to a, second x is also a, third x is also a. Output will be a plus a into a. That is our parse tree. X is replaced to x into x. Again x is replaced by x plus x. First x will be a, second x will be a, third x will be a. Now the parse tree will be a plus a into a. So there is a possibilities of two different parse tree for the same grammar. So this is parse tree 1 structure. This is parse tree 2 structure. So both the tree representations will be taken as a same input, same language. It produces the same output, but in terms of representing the tree structure is entirely different to each other. So that the grammar is called as ambiguous grammar. I think this I mostly understand the ambiguous grammar concepts. Next, closer properties of context-free languages. Just what are the properties are available? You have to we are discussed for property alone. The corresponding explanations, corresponding properties, derivations, theorems, everything will be discussed in the next video. Just what are the properties of context-free languages are closed under union operation, concatenation operation, clean operation, clean star operations. These are all under closed. And some simplification techniques of CFG, removal of unit null productions, removal of unit productions, removal of useless symbols. These are the rules are available in the given grammar means this is not in the simplified form, so we need to be eliminated. So then only the CFG will be executed very efficient manner. So removal of epsilon null production means epsilon productions. Removal of unit production means one non-terminal gives exactly another one non-terminal. Useless symbols means there is no possibility for the capital letter symbols are not in position to derive small letter characters. That means one non-terminal exactly produce non-terminal alone, not for terminal characters. That's why we call it as useless symbols. But this is our next level. These are the simplification techniques, process in the context-free grammar. So corresponding explanations, corresponding example problems will be discussed in the next video. Thank you. Thank you, students.